Hello, welcome to Technoveda Solutions. In this video, we will be discussing about C data types. We'll see what are the different data types we have, how are they stored in the memory, and what are the format specifier used for those data types. So we'll discuss that in detail. Let's begin. So when we talk about the data types, immediately the four basic data types comes into our mind: character, integer, float, and double, which are very common data types used in most of the programming. Along with the qualifiers, what we have: signed, unsigned, short, long. These are all qualifiers. So that will change the size of the data type. By default, the size of the character is 1, integer is 2, float is 4, and double is 8. However, the size of the data type depends on the compiler. It is a compiler specific. We have a GCC compiler where integer size is also 4 and float is a 4. Like that, whenever we start programming, depending on the compiler, we should know what is the size of the data types. These data types are compiler specific. Okay. Now let's see the types of data types in C. How are they classified? We have three basic classifications, broad classifications, we can say: primary data types, derived, and user defined. In primary data type, again, we have the same thing what we just saw: integer, character, float, double, and one more is a white. Integer is used to store the integer values. Character, we know it's a character, 1 byte storage. Character will be stored in terms of their ASCII values. Float value is used to store the real numbers. Double is uh, size is more than the float. It can also store the real numbers. And white does not store any values. Then comes derived. In derived data types, we have functions, arrays, pointers, references, and these are derived data types. So each one we will be discussing in detail. Then we have another set that is a user defined, wherein we have class, structure, union, enum, type def. However, class is not usually used in C programming. We use remaining four are used. Class is more prominent in C++ programming rather than C program. But however, overall the data types can be categorized like this in three different sections: primary, derived, and user defined. Now we should know how exactly these are stored in the memory. Before that, let's understand memory layout of C program. When an executable of the C program is generated, that executable file is divided into different sections of the memory. Starting from the lowest address, we have a text section here, or a text segment, and it is also commonly referred as a code segment. This is where all the instructions are stored. All executing instructions are stored in the text segment. Then we have a next section where we have a initialized data. So this is a data segment wherein we store the initialized data for the data which have either the default value or we have initialized the data. That depends on what storage classes we use. That also we'll see. Then another section we have a BSS section. So this is basically based on the symbols. It is uninitialized data. So block symbol data, or the block symbol segment. So here we have uninitialized data. However, during execution by the executor, it will initialize to 0, even though compiler has kept it garbage. Then we have a heap segment, which is used for all our dynamic memory allocations. Whenever we want memory to be allocated during runtime, then all that runtime memory will be taken from the heap memory. And then from the top, we have command line arguments and environment variables. Command line arguments are the arguments sent for the main function. We'll discuss about that in detail in the coming sessions. Then after that, we have another segment called stack segment. Fundamentally, the stack segment is used for the context switching whenever we have a function call or interrupt invocation. Basically, to store the context of the program, we use a stack memory. However, this can be used to store some of the variables also, depending on what type of storage class we use for the variables. Especially if we have an automatic variable, then we use that will be stored in the stack. Then once it is initialized, it will come to a data segment. So this is how the memory is organized in the C program: code segment, data segment, heap segment, and stack segment. These are the four basic classifications. In data segment, we have a BSS separate section is made, which is for the uninitialized. Then we have another section which is for the command line arguments. These might not be used in all the programming. Only specific program uses these command line arguments and environment variables. Otherwise, you as a user will not define those variables. So as far as general programming is concerned, most of the code what we write will be in the text, and variables declared will be either in uninitialized or initialized data. Okay, then let's see what are the characteristics associated with the variable what we declare. Now, when we say a variable, we know that it is basically a memory location which is read and write accessible. That means we can change the value of that particular variable. That is the reason why it is called variable. Basically, it signifies a memory location in which we can change the value, we can read the memory, and we can write the memory. To identify that, we give a name for the variable. That's the first characteristic. We need to have a name for a variable. Then that name will be associated with one of the data type. What type of data are we going to store in that particular memory location, which is named by that variable? Maybe a integer or a character or a float, whatever the data type we want to have, whether it can be a primitive data type or a derived data type or user defined. We need to have some data type with the variable. Then variable also has a storage class associated with that. So there are four storage classes: automatic, static, extern, and register. As we can see, automatic by default, whenever we don't define any storage class, we just write integer and a variable name, int x, for example. By default, it is taken as the automatic storage class. And if we don't initialize any value, then it will have a garbage value by default. Whereas when we have a variable with a storage class of static or extern, the default value will be 0 for them. Static is a storage class which is used for variation of the life and scope. We'll see how the life and scope varies for the static variables. Then extern keyword is used, or extern variables are used when we want a particular variable to be shared by more than one file or to be accessed by more than one file. Then we use the extern keyword to define the variable, so that we tell that this particular variable is used by some other file also. And then we have another storage class called register. This register storage class occupies a CPU register, and it will have a garbage value by default. So automatic and register will have a garbage value. Static and extend will have a 0 by default. Okay. So default value will be assigned. Now we see in this table how the storage classes have a store where it will get stored, what is the initial value, what is the scope, what is the life. Before that, let's understand what is scope and life. When we say now already we know what is the storage and initial value, that is default value. Scope means whenever we talk about the scope of a particular variable, it is a block or the section where the particular variable can be modified, that we call as a scope, where a particular variable can be accessed or modified. Then that section of the code or that block of the code is scope of that variable. And when we say life, life is said to be the duration for which a variable occupies a memory or memory is allocated to the variable. As long as there is a memory allocated to a variable, we say that variable is alive. Once it comes out of this that life section, then the memory will be deallocated for that. For example, if you have a automatic, as I said, it will be stored in the stack initially. The default value will be garbage. Now this will be within the block. If I define a particular variable inside a function, then that variable is limited to that function. That's a block or a pair of braces. The moment we come out of that function, the variable will be deallocated from the memory. That means its life is over. So the life is also end of the block. So scope and life both are within the block only. The moment it comes out of that block, the variable is memory allocated to variable is deallocated. Whereas if we see the static, by default it will have a zero value, so it will go to data segment directly for the storage. Default value is zero. Then it can be for a static, the scope of the static variable will be within the block or pair of braces. That means that is the within the block only we will be able to vary the value of that, or we will be able to access it. But its life is till that program is terminated throughout the program. That means if I declare a variable inside a function using a static keyword, then even when I come out of that particular function, the memory allocated to that variable is not deallocated. When control goes back to that function again, the previous value of that variable is used for the successive operations. So in such cases, we will be using a static variables. So it can be accessed only within the block. It cannot be accessed outside that function. But the memory allocated to that variable will still be retained even after completion of the function execution. Then we have a extern. This was also stored in data segment with 0 as a default value. This is declared in a global, and it will be having a scope in multiple files. We can use that variable in the multiple files. And its life is also till the termination of the program in which it is used. Then we have a last storage specifier, that is a register, which uses a CPU register as a storage. And by default, the value will be garbage. So this will be within the block and end of the block. The scope will be within the block and life will be within the end of that particular block. But this particular register variable should be used very carefully, because that may overall degrade the performance of the CPU itself if we occupy too many registers So whenever a variable is declared as a register variable, the programmer should be very careful, and it should be used in a very small sections of the code wherever it is absolutely necessary. Okay. Now, coming to a conversion or the format specifiers. So basically this format specifier tells us what format of the variable are we going to print or scan from the console. So we have a various format specifiers, for a percentage C for character, percentage D for a decimal integer, I for a signed integer, U for unsigned integer, O for octal integer, X for hexadecimal integer, either the uppercase or the lowercase. Depending on how we want to print or scan, based on that we can mention various format specifier in the print and scan instructions. Again, continue to same thing. We have for the float, we have a percentage f, exponent format percentage e, and also we have case for the exponential format. Then we have uh, floating point number, whichever is smaller. If you want to have percentage f or percentage e, whichever is the smaller. If you want to have optional access or storage in the memory, then we will give percentage g. And when we have a capital uppercase e is used for the exponential, then uppercase g is used to choose between the percentage f and percentage e. So this choice will be given left to the compiler. It will choose it according to the value which is given for in the console. So for a string we have a percentage yes, percentage percent to only print the percentage sign itself. If you want to print a pointer in a hexadecimal format, then we'll be using a percentage p. So these are format specifiers. Then we'll see some important thing, that is precedence and associativity of the operators. Now here, when we say operator, we can have a unary operator, binary operator, or a ternary operators. When we say unary operator, it will work on only one variable. When we say binary operator, it is taking a two variables, two operands, and ternary will take three. Now, depending on the operator what we use, the precedence and associativity will change. So associativity is basically how it is executing. If we have a multiple operators in the same instruction, from which side it starts evaluating the instruction. Precedence is the importance given to a particular operator. So now all these function call, array, arrow, dot operator, these all are precedence having one evaluator from left to right. Whereas if we see most of these operators like unary, unary plus, unary minus, increment, decrement, logical not, one's complement, indirection, address, these all are the having a precedence too. So if we have an instruction having the this operator and this operator in the instruction, then first this operator is evaluated and then this operator is evaluated. That's what the precedence mean. So lower the number for the precedence, higher the priority for that. But these operators are evaluated from left to right. Sorry, right to left. Then we have other arithmetic operators like multiplication, division, modulus, addition, subtraction. These all are binary operators which will have a precedence of 3 and 4, then evaluated from left to right. Then we have a shift operators, right shift and left shift, have with the precedence 5 and left to right associativity. Then we have a comparative operators, less than or equal to, greater than or equal to. So this will have a precedence of 6, evaluated left to right. Then we have equal and not equal. These are also comparative operators with the precedence 7 from left to right. Then we have a logical operator, bitwise operators, and XOR and OR. Then we have a logical operators, logical and logical OR. And then ternary operator, conditional operator is a ternary operator. So their precedence is given here 8, 9, 10, 11, 12, and 13 respectively. All are evaluated left to right except this conditional operator, which is a ternary operator. When we see some of the examples of the program, we will use this ternary operator and we will have a detailed discussion on that, how exactly it is evaluated. Then other assignment operators we have. So it will have a precedence of 14. So these are compound operators. That is where we will be using two operations in the same way, that is combinations. So this will have a precedence of 14. From right to left, it is evaluated. Then finally, we have a comma operator, which is usually used to separate the variables, which is having a precedence of 15 and evaluated left to right. So that's it in this video. Thank you for watching. If you have any questions, you can put it on the comment. If you like the video, press like, share, and subscribe the channel.